the BMW engine, we're going to measure bore and we're going to measure stroke. And I've just shown you all the tools that we're going to use. So I think you kind of have a pretty good view here. I'm just looking at my, I'm not facing the camera, so I'm not looking at you guys because I'm looking at my screen. Let me just kind of turn this sideways so that you can see it in the camera. Okay, so I'm just going to turn this engine sideways. Turn it sideways. Yeah, you get a better view that way, right? So, okay, so I've got two cylinders here on top dead center, and then I've got this cylinder here, number 2. It's at bottom dead center. So we're going to measure the stroke from the top of the. We're going to measure the stroke from the top of the deck here on the block. Okay, and I'm going to measure down using my vernier caliper. Okay. So I'm going to take my vernier caliper, and on the vernier caliper, I've got something here to measure depth. Okay, so you can see it coming out, right? I can use this here to measure depth. I'm opening up the jaws on the top, but when I open it up here, okay, you can see that my depth gauge is also coming down here. All right, so here's what I'm going to do. I'm going to set it up on top of my deck. Okay, and I'm going to set it up on top of the deck. Okay, I'm just going to kind of put it on the edge. And again, this is just a quick method that I will have you guys do in the shop so that you could figure out displacement for your engines, because I give you these engines. I tell you what it is. I'll tell you, oh yeah, it's an inline 6-cylinder from a BMW. I'm never going to tell you the size, okay? If you were in the shop and you had this engine apart, in order for you to find your specifications, you have to figure out the displacement or the size of this engine so that you could look up the specs, okay? Because you just can't go online to find out all the specifications for an engine based on the size of the engine. You could probably find bore and stroke, all right? But when you're looking in a repair manual, you generally have to find out year, make, model of the vehicle that has the engine. And then once you find that out, year, make, model, okay, then you find out the engine that's in that particular car, then they can give you all of the specifications. That's generally how you can look up specifications for an engine. You have to find out what year, make, and model the car that the engine was in, it was installed in, and then you can find it, okay? So now, I'd make you guys do this, but you're not here, but whatever. Let's just measure the stroke. So again, I'm going to turn this on. I'm going to power it up. I'm just going to bring it down. I'm going to bring it down to the top of the piston. And if you guys can see, the piston is slightly different, okay? So it's not flat on the top, all right? And you guys can clearly see it's only kind of flat in this area here. And then you've got these areas here, okay? And these areas here are for the valves. They're called notches. And these notches are there for the valves, all right? So when you're looking at it, you can clearly see that this particular engine has 4 valves per cylinder because there's 1, 2, 3, 4 notches in the piston. So what I'm going to do is I'm just going to bring down my vernier caliper. I'm just going to go to the top right here, okay? And hopefully it gets me close, all right? Okay, so I've got it down, but I didn't inches. Okay, let's run it down again. I'm going to run it down again. I'm just double checking my fit. Okay. All right, so I've just measured 87 on my vernier caliper here. I've just measured 87.84. Okay, 87.84. All right, I'm going to write that down, and you guys write this down too. So 87.84. All right, it's kind of moving around 87.86 now, but if you guys see the measurement here, okay, 87.86 is what's on there right now. Okay, 87.86. So that's our stroke. Okay, Let's write that down. The stroke on this engine, 87. Stroke, 87.86. Now we're gonna measure the bore, and the bore we're gonna measure the exact same way that I just measured on the Volkswagen's piston. All right, we're gonna use telescoping gauge. We're gonna put it in. We're gonna install it into our cylinder. Okay, and I'm gonna measure this one because it's empty. Okay, and let it come out. Okay, and I don't want it to spring out too fast. I want it to kind of come out gradually. So this kind of come out. For some strange reason, there we go. We've got one side sticking. So now, okay, what am I gonna do now? I'm just gonna do the exact same thing that I just showed you guys earlier. I'm not gonna lock it. I'm just gonna kind of spin it around in my cylinder. I'm gonna make sure that it's touching, okay? And again, you guys should be doing this, right? Okay, it's spinning around, it's spinning, it's kind of tight here. So let me just move it, let me make sure it's straight. And I like to center this telescoping gauge. So left to right, I like it to be centered. So I don't like the way this looks. It's kind of sticking, so bring it back out. Good. And I like it centered. That's just me. Doesn't have to be centered. I'm going to spin it. And I can feel that it's touching all the way around. I'm just going to lock it. So now that I've locked it, and when I pull it out, okay, these don't come out any further, because if you leave it unlocked and you pull it out, they will just spring out. I've had these things come apart many times, okay? Sir, something's wrong. Yeah, I know, you forgot to lock it. These things spring right out because there's nothing to hold it in place, right? There's just a little spring in there that allows these things to kind of spring out. All right, so now that I've got this measurement here, okay, all right, with this gauge, okay, now I use my vernier caliper. And again, this is just a quick means to check it, okay? I'm going to be able to measure the bore or the diameter of my cylinder. I could do this too. And let's just see how accurate it is. I can take this and I could just literally open it up. And let's see if we get pretty close. And sometimes the students do that too. They'll do that too. And again, it's just very, very close, but you want to be as exact as possible. So right now, my measurement right now, 84. Not bad, okay? So right now, this is 84.81. That's what I've got for the diameter of my cylinder. But let me just double check with this now. So we've got this right here, okay? And what I'm gonna do, okay, and again, I showed you, okay, I'm gonna take my vernier caliper. I'm just gonna, see if I can do it in front of the camera. I'm just gonna open up the jaws, okay? So look, 84.97, right? If you guys are looking at this here, you can see it 84.97. That's what I've got. Okay, let me just double check. Yep, so I'm just double checking. 84.97 for the diameter or the bore of this particular engine. So now we've measured bore and stroke. Let's calculate together as a class, and you guys can throw it up in the chat. All right. I don't have my calculator here, but we can do it. And if I look at it as a class, good. All right, I can pull up the chat here. All right. You guys calculate the displacement of this engine just based on some very rough figures. Okay. So with these rough figures, we should get fairly close to what the actual displacement is on this engine. And then once we do that, we can figure out what kind of car did it come in, right? So let's do this right now. We're going to do this together as a class. So in order for us to find the specifications for this particular engine, I have to find out what the year, make, and model this particular engine came in, all right? So let's figure out displacement of this engine first, all right? Once we figure out displacement of the engine, and it should be fairly close, okay? Then I'm going to make you guys go on the internet and try and figure out what year, make, and model this engine came in, and then once we do that, guy, once we do that, that's the end of this little kind of lesson, because that would be the way that you would be able to find out the specifications for this. Because I'm going to go into Electude, and I'm going to show you how we can find all the specifications for this engine using Electude, okay? So normally we use something called Shopkey, which is a Snap-on product. We've got Electude now, and Electude has something called MotoLogic, and that MotoLogic system gives us specifications of thousands and thousands of different vehicles, including thousands and thousands of different engines, okay? So let's figure it out together, all right? All right, so our bore is, let me go back to the other, I'll go back to the other computer. So we're still recording this, but I'm going to run back to the other computer. I'm going to turn off the spotlight for this, all right? I'm going to undo the spotlight. Good. All right, so now if you guys are looking, you're probably seeing my classroom. Now we're back at my desk. Or stroke is 87.86. Or it is 84.97. What do we have to do first? First thing that we've got to do is that first. Now our radius is 4 and let's try to keep as much numbers as we can. We're going to get close. We're not leaving up.
Oh my gosh, I'm so sorry. This microphone here was on mute, so I was talking and you guys couldn't even hear me. So what I just did was I changed the stroke, 87.86 millimeters into centimeters. I changed the bore, 84.97 millimeters into centimeters, okay? And then we calculated the radius, okay? Radius is bore divided by 2, okay? So we've got 4.284, okay? 4.2485, sorry. Let's plug these numbers in. So for engine displacement, okay, our formula is pi r squared times height times number of cylinders. Now, let's see if somebody was paying attention here, okay? Let's ask William. William, how many cylinders do we have in this engine? How many cylinders does this engine have? The engine we just measured. Yes. How many cylinders does that engine have? The engine that we're looking at, the BMW engine. So we just measured the bore and we measured the stroke. And again, it's very rough, but do you remember how many cylinders it has? It sure does. He's absolutely right. William says it's got many. It's got many, many cylinders. David, tell him number after 5. You got it. Yeah. So David, tell us what the number after 5 is. Thank you, Hansa. Dave's gonna go, what are we talking about? Oh, I just woke up. So go ahead, William. What is it? How many cylinders do we have? So yes, we've got many. So we got 6. Good. So the number of cylinders is 6 because it's a BMW, okay, L6. All right. So what L means is that it's inline. So it's L6. If it was a V6, it could be a V6, right? If it was horizontally opposed, it would be an H6. If it was a W, it would be a W6, and so on, okay? So L for inline, V for obviously V, okay, V6, H for horizontally opposed, and then W if it was a W style block, all right? So here we go, 3.14, and look, we calculated the radius already, 4.2485. The height is our stroke, 8.786 times the number of cylinders. It's a 6, okay? So let's do this. We've got some really long numbers here. 18.0. I'm just going to round it off to 0.5. 3.14. Right, so we got that times. Wow, 56. Wow, 497. Okay, so we just calculated displacement ever so roughly, okay? Not 100% precise, but we got something here that's pretty close, okay? So what we got here, and our calculation is 2,987.74 cubic centimeters, right? Because we had centimeters, right, squared, right? And then we've got centimeters here, right? So you got centimeters squared times centimeters gives you cubic centimeters, right? So it would be 2987.74 cubic centimeters, right? CC, okay, centimeters cubed, or ML. So when we have to figure out the displacement of this engine, displacement for this engine is 3 liter. Why? Because it's 2.987, so that's bigger than 50. So we round it up to a 3 liter, all right? The manufacturer is not going to tell you that this engine is 2.987, okay? If the manufacturer was to say that it was a 2.9 liter engine, okay, this number here would have to be less than 50, all right? So it could be anywhere from 2,901 all the way up to 2,949, and then that would make it a 2.9 liter engine, okay? So now that we've got a 3 liter inline 6-cylinder